So, good evening, everyone. I hope you all guys are doing great and having a quick revision and revising every day for your upcoming examination of GPAT. Is my screen and voice are clear to everyone? That's great. So, okay. So, today we are going to start our discussion on the two topics, which includes the semi-solid dosage forms and the aerosols. In the previous class, we have discussed about the capsules and the parental dosage form. So, in this class, we are going to discuss about the aerosols and the semi-solid dosage forms. So first, let's coming to the aerosols. So aerosols are nothing but the pressurized dosage forms. So which means that it consists of a container in which the drug is suspended or dispersed under the pressure. So it can be the drug can be dissolved, dispersed, or suspended or compressed in a liquefied gas. So aerosols are majorly these are of suspensions of small solid droplets or liquid suspension in a gas or a vapor. So these are generally pressurized contents. So these are delivered via a device. So device here the aerosols comes under the combination of drug device combination. So this point should be have to remember the aerosols comes under the category of drug device combination. So these are the advantages like those can be removed without contamination, stability, enhancement, balance of oxygen and moisture sensitive drugs. Because the drug is enclosed within a device, so it has a uh, instability issues caused by the moisture and oxygens are prevented by the device. While coming to the disadvantages, these are costlier. Aerosol packs may be stored in cool places because the container should be closed in a cool place, and the proponent may cause the toxic reactions. So mainly while coming to the aerosols, so
అంటే ఇది వేరే క్లాస్ లో అంటే ఇప్పుడు
do you guys know the types of the aerosols? What are the types of the aerosols? Mainly the inhaler products, mainly three types. The which is known as first one, the pressurized and metered dose inhalers, dry powder inhalers, and nebulizers. So these are the mainly three types of inhaler compounds which are used in the market for the both local and systemic delivery. So while coming to the aerosol, So these are mostly used for the local delivery into the respiratory system, our lung system. So mainly while coming to the components of the aerosol, the container is the most widely important component of an aerosol system.
सुरुवात
Generally,
नाही
it
का
can be made up of
तुम्ही
metal or
नाही
glass.
नाही
So
नाही
most widely
दुसरा
used
कोर्स
is
आहे ना
the
नाती येत
metal,
नाही अभ्यास
mainly thin
करायचा तुला
plated steel. The other material is the aluminium. So these kind of materials should not be used in the pure ethanol or water as may cause erosion. So that's why the aluminum or tin which is stored should be coated with a sufficient material so that it prevents the erosion of the container in which the drug formulation is stored. So generally, guys, could you say me that chlorofluorocarbons are used as propellants or hydrofluorocarbons? In nowadays, in aerosols, which of the following are used as propellants? Chlorofluorocarbons or hydrofluorocarbons? Do you guys have any idea? Does the chlorofluorocarbons are used as propellants in the aerosols nowadays or hydrofluorocarbons? Hydrofluorocarbons. Yes, guys. Because the chlorofluorocarbons have caused the ozone depletion. That's why they have been banned by the all companies. And nowadays, only the hydrofluorocarbons are used as propellant in the aerosol systems. So generally, the pressure, the pressure inside the aerosols is range from the 140 to 180 psic at 130 degrees Fahrenheit. So this is the normal pressure of the aerosol, which has the pressure of the 130 to 140 to 180 psic at 130 Fahrenheit. Guys, do you know what is the relationship between the psic, picopascal in psi? So there is a relationship between the psic and psi is, so 1 psic, so psic is equal to psic is equal to psia minus 14.7 atmospheric pressure. So this is the relation between the psic and psia. So mainly the aerosols have many components. The aerosols can be of space spraying, surface coating spray, foam spray. So by in form of different spray in different sprays, the drug component can be coming out. So mainly the main important components are the metering wall component, which includes ferrule or mounting cap. So the mounting cap is used to attach the wall to the container. It's made up of the thin plated sheet through aluminum can be used. So here the components are important and the material of construction of this component is very important. So you have to get revised. So for ferrular mounting cap, which is used to attach the wall properly to the container, is made up of thin plated steel or aluminum. The wall body or housing is made up of nylon or derlite. The stem is made up of or also nylon and derlite. The gasket which is nothing but a rubber ring, which is made up of Buna and neoprene rubber. And generally, it consists of also a spring, which is made up of stainless steel and dip tube. Dip tube through which the dip tube is something like this, through which the contents from the aerosols enter and are expelled outside. So it is made up of polyethylene or polypropylene. So as I mentioned, propellant. So propellant is responsible for the proper pressure within the container and expels the product when the valve is open. So generally, our drug can be dissolved or dispersed in the propellant. Generally, guys, at normal atmospheric pressure, does the propellant exist in gas phase or liquid phase? Tell me, guys, the propellant in the normal atmospheric pressure exists in gas phase or liquid phase? Answer me, guys. In normal atmospheric pressure, the propellant exists in which phase? Yes, they exist in gas phase, but under pressurized condition, these are converted into liquid, and in that liquid, the drug is dispersed or suspended in a aerosol. So as I mentioned that mainly two types of propellants are used, which mainly include the fluorinated hydrocarbons. So halogenated hydrocarbons means fluorinated and chlorinated. So fluorinated and chlorinated are used for the. So let me have point here. 1 minute, guys. So the fluorinated, the fluoro and chloro hydrocarbons are used for respiratory purpose. For respiratory purpose mainly. And mainly the propane, butane, etc. are used for the topical purpose. The propane, butane, isobutane are used for the topical purpose, while the fluorinated and chlorinated hydrocarbons are used for the respiratory purpose. So next, other propellants can be of soluble gases like nitrous soluble gases, which includes carbon dioxide and nitrous dioxide, and they can also be other gases. So the main important comes in the aerosols is this numbering, the numbering of this. So this numbering is very, very important, guys. This numbering consists of a 3 letters. So let me first show you how to do numbering. 1 minute. So it consists of the 3 numbers. So let us consider one number as 114. So 114, the first number, the first number digit indicates the carbon atoms, the number of carbon atoms. The second digit indicates the number of hydrogens, and third number digit indicates number of fluorine or chlorine. Generally, it indicates chlorine. So by this way, we have to determine the name of the propellant. So I think so in NIPER 2023, they have given a number and they have told to decode the name of that propellant. They have given like propellant 14114 and they have told to decode the name of that propellant. So which includes the dichlorotetrafluoroethane. So these should be remembered, guys, for you. The first letter indicates about the number of carbons. The second indicates the number of hydrogen atoms, and fourth and third one indicates the number of fluorine carbons. So guys, let me say you, uh, guys, what would be the name of 152 propellant? Propellant 152. Come on, guys, say me. What would be the name of propellant 152? Come on, guys, what would be the name of propellant 152? What will be the name of the propellant of number 152? Do you guys have idea what will be the name? Difluoroethane. Yeah, great. It will be difluoroethane. Great, guys. So you have to be remembered, guys. It will be not dichloro-pentafluoroethane because as it indicates the one means it consists the n minus one of carbon means it consists of two carbons. Five, five. So n plus one. So it will contain four hydrogens and two fluorines. So by which it would be difluoroethane. So likewise, you have to guys remember this. So another one important law while coming to the aerosols is the partial Dalton's law, which indicates that the a pressure exerted by a container is equal to the partial pressure of the individual gases present in that container. For example, a container consists of three gases: gas A, gas B, and gas C. The total pressure exerted by this container will be the summation of these three pressures. This is known as Dalton's law. So while coming to the Raoult's law say that lowering of vapor pressure of liquid by the addition of another substance states that depression in the vapor pressure of solvent upon addition of solute is directly proportional in the solution. So there can be a positive deviation or negative deviation from the Raoult's law. So next type of inhalation devices which are used in the aerosols, which include meterized dose inhalers, nebulization, dry powder inhalers. Guys, could you say me that in which of the following the propellants are absent? In which of the following devices the propellants are absent? Propellants are absent in which devices? Meter dose inhalers or DPI or nebulizers? Come on, guys. Does the nebulizers also contain the propellants? Yeah. So nebulizers and DPI lack the propellant. That's why these are more attracted towards the customer, because there are many stability issues occur with in presence of the propellant. So while coming to the metered dose inhaler, which only contain the propellant, in which the drug is suspended or dissolved in the propellant under the high pressure. So whenever the valve, yes, so whenever the valve is activated, the propellant comes out in a force. It propellant get evaporates and deposit the drug particles. So nebulizers, so generally the liquid solutions are administered via the nebulizers, which include jet nebulizers and ultrasonic nebulizers. So in jet nebulizer, the droplets of the liquid are formed by passing the air, while the ultrasonic nebulizers, the droplets are formed by piezoelectric transducer, which includes the ultrasonic sounds. So dry powdered inhalers, in dry powdered inhalers, only the powder is present, and the patient causes the force to inhale the compound. So next, propellant filling methods are very, very important. So we have to know the propellant filling method. Mainly two types of methods are generally used for the filling of the propellant in the metered dose inhaler, which includes the cold filling and pressure filling. So in cold filling, the product concentration is cooled from 0 to 10 degrees Fahrenheit and then added to the containers. Then propellant is refrigerated, then added to the container as a cold liquid. And pressure filling, pressure is nothing but the through pressure, the propellant is added into the container. So now tell me guys, which of the following would be the cost effective for the companies, pressure filling or cold filling? The most widely used propellant filling method would be pressure filling or cold filling. Yes, guys. The one of the most convenient, because there is no need to maintain the such stringent refrigerated conditions. That's why pressure filling is most widely used method for the propellant filling in the metered dose inhalers. So next, another important comes with the specifications, the for the quality control test for the uh, aerosols. So which includes mainly flammability and combustibility test. So guys, could you say me the what is the apparatus used for the flashpoint testing? Say me the equipment or apparatus which is used in the flashpoint. Yes, bag. It's not bag apparatus. It's tab open cup apparatus. So in Flashpoint, yes, guys, great. You are able to get recall your everything things. So the Flashpoint, the main important is the standard tag open cup apparatus, in which the aerosol is chilled to a temperature of minus 25 degrees Fahrenheit. This temperature is also very, very important, guys. You have to remember here two things in the Flashpoint. The first thing is the apparatus which is used, which is standard tag open cup apparatus. The second thing which is to be remembered in the flashpoint is the temperature, which is minus 25 degrees Fahrenheit. To transfer to a test apparatus, the test liquid is allowed to increase temperature is slowly, and the temperature at which vapors ignite is known as flashpoint. So what we do is first we take our liquid in a apparatus, and gradually the temperature is raised. So at a particular temperature, the vapors get formed, and those vapors are get ignited. At the temperature at where the vapors get ignited is nothing but the flash point. Next, flame projection test. So flame projection test is mainly used, indicates the effect of aerosol formulation and the extension on the open flame. So in this test, nothing is done. A flame is taken. On the flame, the aerosol product is sprayed. Depending upon the nature of formulation, the flame is extended and the length is mentioned with a ruler. So could you say me that for example, I have a sample and I want to determine the moisture content in that sample. So which of the following technique will be used to determine the moisture content in a sample? Tell me, guys, which of the following technique is used to measure the moisture content in a compound? I'll give you a hint. Gas chromatography, okay. Carl Fisher, yeah, Carl Fisher. So Carl Fisher is the most widely used technique for the determination of moisture content. And what are the composition of the Carl Fisher reagent? Guys, could you able to recall the composition of the Carl Fisher reagent? This question has been asked in the NIPER 2021. What is the composition of the Carl Fisher reagent? Can anyone tell me what is the composition of the Carl Fisher reagent? Guys, come on, recall it. What is the composition of the Carl Fisher reagent? You have to know, guys. You have to get recall it, guys. What is the composition of the Carl Fisher reagent? Recall, because it has been asked in the, yeah, it consists of the iodine, sulfur dioxide, and alcohol. Great, guys, great. Yes, yes. It consists of iodine, sulfur dioxide, and a solvent, which is basically alcohol. So next, as I mentioned, the different properties. So the vapor pressure is measured by the pressure gauge and the can punching device. Density is measured by the hydrometer or cyclometer. Moisture content by the Carl Fisher method. Great action. Gas chromatography is also used. Propellants. So identification of propellants by Carl Fisher titration and infrared spectroscopy. And come on, me guys. The particle size determination of the aerosols is done by which equipment? Particle size. Particle size determination of aerosol cascade impactors, guys. Great. So let me here develop a MCQ for you guys. 1 minute. So which of the following particle size determination? So A includes cascade. Wait, please. Cascade impactor. Next gen impringer. C multi-stage impringer. D all. Tell me, guys. Tell me the answer for this question. What is the answer for this MCQ? Which of the following is used to determine the particle size determination? Cascade impactor, next gen impringer, multi-stage impringer, all. Come on, guys. Answer this question. Answer to this question. Great, guys. Great. So these all equipments are used to determine the particle size in the aerosol formulation. So the foam, okay. The foam test of the aerosols is done by which equipment? The foam test of the aerosol. The foam test of the aerosol is done by the which equipment? Foam test. The foam test for the aerosol is done by which equipment? Yeah, great. It is done by the rotational viscosity. Great, guys, great. And the Department of Transport test is done for the which of the following? Department of the Transportation test. Department, yeah, great. So these all are the minute, yeah, DOT, Department of Transportation. So these all are the small important things which are have to be measured in the, you have to be remembered in the aerosols. So there is also a holography which is also used to measure the particle size. So So let me. So as I mentioned, that the particle size distribution is measured by the cascade impactor and the light scattering day methods have been used to determine the cas particle size for the aerosols. So these are the other which can be used like foam stability. The foam stability is nothing but the life of a foam can range from the few seconds to 1 hour depending upon the type of formulation. Some of the foams which are released from the formulations can stay up to 1 minute, can stay up to a few seconds, can stay up to few hours. So depending upon the formulation which is used, the foam stability determines. So now let us have. Is there any doubts which you have, guys, in the aerosol, so that I can move into the next topic of semi-solids? Do you guys have any doubt? Any doubts in the aerosols? Any doubts in the aerosols, so that I can move into the next topic, semi-solid dosage forms? Great, guys, great. So let me now share you a blank screen where I'm going to. Okay. So semi-solid dosage form. So semi-solid dosage form are used for the provide as a local as well as systemic effect. So let me first put down the everything. Semi-solid dosage forms. So semi-solid dosage form generally are used for the both local and systemic effect. So these are the generally these are applied to the mucous membrane or the mucous membrane mostly, or to skin. These are generally applied to the mucous membrane or to the skin. So the different types of the semi-solid dosage forms include ointments, creams. Yeah, come on, guys. You all tell me, guys. The third one is gels. What else? Paste. Yeah, great, guys. Jellies. Okay. Jellies and the gels comes under the plasters also comes under the semi-solid dosage form. And sixth one is jellies. So these are the different semi-solid dosage form which have to be remembered to you in the guys in the mind. Lotions and liniments. Yeah, but lotions comes more under the liquid dosage form because the lotions generally have very low viscosity. Generally, lotions have very low viscosity. So let us have a discussion towards the ointments. Let us first cover the topic ointments. So come on, guys. So there are different types of ointments. So based upon the application where they are applied, they can be divided into three types: epidermic, endodermic, and diadermic. So tell me, guys,
450 అంట
the
అదో
epidermic are what you meant by the epidermic ointments. Do you guys have any idea? Do you guys have any idea about the epidermic ointments? Do they show the local effect or systemic effect where they are applied? Do you guys have any idea on epidermis grade layer on the skin? Yes. Is there a used for the locally or systemic effect? Does the systemic effect? Yeah, great. So these are only for the local purpose and on the skin. Great, guys, great. So while yeah, great. So while coming to the endodermic, so what about the endodermic, guys? Tell me about the endodermic. What do you understand by the endodermic ointments? Yeah, they are topical, great. So these are also applied into the skin, applied on, so these are applied on the skin. So 1 minute. So these are applied on the skin. These are only partially absorbed. These are not fully absorbed. These are only partially absorbed. So while coming to the diadermic, come on guys, now tell me about the diadermic. Diadermic also applied on the skin, but these are for the systemic effect. I think so. These three main trick. Yeah, great guys, great. So this is the main three classification of the ointment based upon the application. So so while coming to the creams, as we know that creams are emulsions or suspensions. Creams are emulsions or suspensions. Tell me guys. Yeah, emulsions. Yeah, the creams are the emulsions, while the jellies are the transparent or transparent thick viscous fluids. So let me here right. So creams are the transparent. Yeah, great guys. So does the diadermic includes the release of the drug from the patches? Yeah. The diadermic mainly ointments in which the drug is released from the skin and it is absorbed to the skin and it enters into the systemic circulation. It is meant for not only local effect but it's meant for the systemic effect. Diadermic. So these are the transparent or transparent and transparent. So now we will tell me guys some of the important things. I think you guys all have idea about the gels. So let me say me some of the what is meant by aerogel. What is meant by aerogel, guys? What is meant by aerogel? What do you guys understand by the terminology aerogel? Do you guys have any idea about the aerogel? Pressurized packing system. Aerogel. It comes under the classification of the gel. So what do you guys remember by the aerogel? Aerogel. So as we know that let me draw one structure. The gel consists of a structure. It consists of a matrix in which the drug is entrapped between the matrix. The solvent or whatever the drug is entrapped between the matrix. So whenever this solvent is replaced out with air, then the solvent removed under the hypercritical network and doesn't streak. So because the solvent is removed from the gel, but the gel matrix do not spring due to the entrapment of the air. So this is known as aerogel. This is known as aerogel. Another terminology which is known as zero gel. Yeah. So what is meant by zero gel? Okay, so let me repeat. So as we know that gels, so gels consist of a matrix. So gel consists of a matrix, which is this matrix is generally formed by the polymers like sodium alginate. So this matrix, generally in this matrix, the solvent is entrapped. So whenever this solvent which is entrapped within the matrix is replaced by the air, then this gel which lacks the solvent in its matrix but consists of the air in place of solvent is known as aerogel. I think it is clear to you guys. Yeah, great. So now let us have a discussion to the so not as zero gel. So what is meant by zero gel, guys? What is meant by zero gel? Understand something. Framework of gel without dispersion medium. Great, great, Vivek, great. So it's the framework of the gel without the medium, without the liquid. No solvent is present. In aerosol, in place of the liquid, the air was entrapped in the network. But in zero gel, there is no air, no solvent. So no solvent, nor air. While in aerogel, the air is entrapped in place of solvent. I think so. These two terminologies have been getting clear to you guys. So next, uh, so generally, once tell me the polymer which is used in the preparation of the gel, does it get dissolved or do it get swell? What happens? In gel, we use the hydrophilic. So let me say you. So which of the following in forming gel do you so let me create an MCQ for you guys. So in the preparation of gel, which polymer is used? One, hydrophilic, hydrophobic, both, no polymer used. Tell me answer to this, guys. In the preparation of gel, which type of polymers are used? In preparation of the gel, which type of polymers are generally used? Hydrophobic? No, 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 no. In the preparation of the gel, remember, guys, in the preparation of the gel, we only use the hydrophilic polymers, which two do not get dissolved. They only get swell. These are the special type of polymers. Whenever they come interact with the solvent get entrapped within their matrix and the polymer gets swell. So that's why due to the swelling, that's why these are known as gels. So another question for you guys. The paste show which flow? Simple, guys, simple question. A plastic, the pseudoplastic, the dilatant, the Newtonian. Come on, guys.
అనుకో నువ్వు అక్క ఎక్కడండి మ్యారేజ్
So
నాకు అవ్వేది ఉంటాయి ఎవరికి జరిగిన నేను బాగా
yeah, so the pace show the dilatant flow, guys. So these have to be also remembered to you guys. The pace shows the dilatant flow. So the paste show the dilatant flow because the concentration of the solid in the paste is so much higher when compared to the ointment. That's why they show the dilatant flow. So some of the important terminologies which are we going to discuss. First one is the inhibition. So tell me, guys, what is meant by inhibition? What do you guys know about the inhibition, guys? Some of the terminologies are very important, which includes inhibition, swelling, synersis, and shrink. So you have to, guys, answer me. What is meant by inhibition? Do you guys have any idea about the inhibition?
ఎవరు చెప్పట్లేదు
Absorb water and swell. Then what? If it absorb water and swell, yeah. So great, Vivek. So inhibition is nothing but the taking the liquid, but it does not get swell. It shows no swelling. So while coming to the swelling, it takes the liquid and gets swell. Yeah, well, great, guys. So while coming to the synersis, so what is meant by synersis, guys? What is meant by synersis? Synersis. Do you guys have any idea about the synersis? Synersis. Do you have any idea about the synersis, guys? So the dispersion media gets squeezed out. Yeah, yeah, yeah. Great, great, Shiva. It gets squeezed out, and the gel gets shrink. So I think so. These three terminologies have been get clear to you guys. So another, whenever guys, could you please show me the types of drug transportation mechanisms through skin? What are the different types of transportation through which the drug enters into the skin? Come on, guys. What are the different transportation mechanisms or absorption mechanisms? What are the absorption mechanism, guys? Guys, come on, quick, quick. Everyone must have to be interactive, passive, active. Okay, active, passive. Okay, in passive, eh, there are many types: transcellular, paracellular, etc. So, provide me, guys. What are the different types of absorption mechanism through skin? Guys, you have to be quick. Paracellular, yeah, great. Next, paracellular, yeah, great. Trans epidural and trans follicular, great, guys, great. Transcellular. So, for the transcellular or paracellular, for which of the following it requires more hydrophobicity? For transcellular or paracellular? For transcellular or paracellular? Yeah, great. Because transcellular is nothing but, let me draw a diagram. For example, this is a cell and this is a cell. So passing of a drug molecule through the cell is transcellular. Well, passing between the junction is known as paracellular. So generally for the drugs which are generally of higher hydrophobicity are generally follow the transcellular pathway. So general, there are factors which influences the permeability of the compounds to the skin. So generally when the hydration increases, hydration of skin increases, what happens to the permeability, guys? Come on, say me. Permeability. For example, I have
Increase.
hydrated my skin. What will be the permeability? It will increase or decrease? It will increase. Great. Great, great, guys. Great. It will increase. If I increase the thickness of the skin, thickness of skin is increased, then the permeability decrease. Great, 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 guys. Great, great. So there are many other different types of factors which influences the permeability of these drugs to the skin, which maybe includes the type of the skin. Because in our whole body, the skin is not uniformly have the uniform thickness. Some of the organs like hand palm has the more thickness of the skin, and some of the areas the thickness of the skin is different. So also there are many different. So another important discussion which have to be done in the ointments is nothing but the ointment basis. Ointment basis. So generally, the ointment are nothing but the suspension, or we can say a dispersion, in which our drug or API is dispersed or suspended in a ointment base. So come on, guys. Say me what are the different types of ointment bases which are used in the preparation of the ointment. Come on, guys. Say me. What are the different absorption base? Great. Okay, absorption base. Next, oleogenous base. Great, great. I think so. You guys are able to recall everything. Oleogenous base. Water washable. Great. Water removal. And then emulsion base. Great. So let us have a discussion regarding the each and everything. So first one is the oleogenous base. 1 minute. So oleogenous base. So oleogenous base mainly made up of the fats and oils. Fats and oils, and generally the examples includes petrolatum. Petrolatum. Guys, provide me the another name of the petrolatum. The petrolatum is also known as. Soft paraffin. Great, great, guys, great. It's also known as soft paraffin. Guys, here you have to remember the other names also, guys, because these are the possible questions which can be asked. Next, petrol atom. We can also use the hard paraffin, and liquid paraffin. Guys, provide me the synonyms of the liquid paraffin. What are the synonyms of the liquid paraffin? What are the different? Yeah, mineral oil, or it is also known as liquid petrol atom. Liquid petrol atom. So next, while coming to these are mainly used for the hydrophobic drugs only. The oleaginous bases mainly used for the hydrophobic drugs only. So next, we are coming to talk about the absorption bases. So absorption bases are the water have the water absorption capacity or the emulsification property. So which includes wool fat. Guys, provide me the synonym of the wool fat. Wool fat is also known as wool fat. Lanolin. What is meant by the hydrous wool fat? The hydrous wool fat is also known as, yeah. So the wool fat is also known as anhydrous wool fat, anhydrous lanolin. Sorry, anhydrous lanolin, and the hydrous lanolin. Hydrous wool fat. Sorry, hydrous wool fat is called as lanolin. See, guys, here you can get confused. The wool fat is anhydrous lanolin. If we get hydrate the wool fat, then we get the lanolin. Next, other one are wool alcohol, beeswax, cholesterol. Guys, do you know the synonym of the aquaphor? Aquaphor. Aquaphor. Do you guys know the name of the aquaphor? What is the synonym of the aquaphor? The aquaphor is also known as. No one able to recall it. Aquaphor. Do you guys listen about the aquaphor before? Do you guys know about the aquaphor or something? The aquaphor is also known as hydrophilic petrol atom. Petrol atom. So other base of the water miscible bases. So water miscible bases which forms the water miscible bases which form the water miscible bases which form the emulsions, and there are also water soluble bases. Examples of water soluble bases, guys. Provide me the examples of the water soluble bases. Water soluble bases. Can't you guys able to remember one classical PEG? Yeah, great, great. So the water soluble basis includes the example of PEG, polyethylene glycol. Provide me the synonyms of the PEG. PEG also known as one of the is the macrogol. Another one, it is also known as PG is also known as PG is also known as Carbovax. Carbovax. So these are some of the important, and the along with that, the ointment also contains the other components like preservatives. So I'm not going to give the examples of the preservatives, as you guys know the examples of the preservatives. It also consists of the humectants. Example of humectant, guys. Humectants. Example of humectants: glycerin, great, and sorbitol, PEG, etc. It also contains the permeation enhancers. penetration enhancers. Examples of penetration enhancers. DMSO, great. Other examples of the penetration enhancers. DMSO. Other examples. Come on, guys, you have to be quick. You have to recall all the examples because in order to score great in the SUTEX, the only key is to remember all the possible excipients. If you remember the excipients, then you are going to do great in the pharmaceutics. So, which includes DMF, dimethyl formamide, Queen 80. Yeah, great. Urea, sodium taurocolate, alcohol, etc. These are also different tests. So, while coming to the quality control test of the quality control EDTA, yeah. So, quality control test of the ointments. Ointments. So, while coming to the quality control test, guys, provide me the equipments which are used to determine the viscosity. Viscosity is determined by. Viscosity is determined by. The viscosity of ointments is determined by Brockfield viscometer. Oh yeah, Brockfield, Oswald. So most widely used as Brockfield viscometer. Great. Brockfield viscometer, penetrometer. Other equipments used as extrusion rheometer, etc. So the test for the absorption. That next test is the test for the absorption in ointments. Could you guys please say me the names of the tests which are used for the test for the absorption of the ointments? Come on, guys, you have to be quick. You have to be quick. Diffusion cell method. So used are the Bliss test and Johnson test. Next, for these are the about the test of absorption. Next, while coming to the crystal habit, guys, provide me the equipments which are used, techniques which are used to determine the crystal habit. Crystal habit. First, tell me what is meant by the crystal habit. What is meant by crystal habit? Do you guys have any idea about the crystal habit? What is meant by crystal habit? What is meant by crystal habit? Outer appearance, yeah. Does the amorphous form have a crystal habit? Let me frame a question here. I have an amorphous form. The something like celecoxib amorphous form. Its crystal habit is. So it should be cubic, orthogonal, needle, none. Provide me the answer for this question, guys. What is the crystal habit of the celecoxib amorphous form? Come on, guys. I want everyone's answer in this question. I want everyone's answer. What is the crystal habit of the celecoxib amorphous form? Great, guys. The amorphous form do not possess any crystal habit, so it is none. Great, guys. Great. So the crystal habit is determined by the XRD, X-ray diffraction, or by the optical microscopy. So next, for the texture, to determine the texture of an ointment, we can use the equipments like spreadometer, or extrusion viscometer. For the skin sensitivity, guys, could you able to remember what is the for the skin sensitivity test? Which of the following tests are done for the skin sensitivity? Patch test, yeah, but I want the specific name. Do you guys heard name about the Drake's test? Drake's test. Do you guys have heard name about the Drake's test? So which animal is used in the Drake's test? Which animal is used? Yeah, rabbit. Great, 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 guys, great. So other test is the open epicutaneous test. Next, so I have a question for you guys, MCQ. So let me frame the MCQ. So the creep test is for viscoelasticity, polymorphic form determination, rigidity, all. Tell me, guys, answer for this is the creep test is used for the ointments for which of the following parameter to be determined. They use it to determine viscous as elasticity of polymer of ointment, polymorphic or rigidity of ointment, or it is used for the all. Come on, guys. I want everyone's involvement. There are 58 students in the Zoom meet. Everyone should be involved. Yeah, yeah, great, guys. It is used for the viscoelasticity. So mainly the creep test is used to determine the viscoelasticity of the ointment. So generally for the eye ointment, the hydrocarbon base are generally used. So as you have known the idea about the PG exists in the different molecular weights. So and the different molecular weights has the different solid state. So PEG large molecular weights, large PEG molecular weights like 2000, 5000 exist in which state, guys? It exists in solid, liquid, or semi-solid. The PEG large molecular weight exists in solid, semi-solid, or liquid. Large molecular weight, large molecular weight. The PEG large molecular weight exists in the solid form, while the PEG of the less molecular weight, which includes less than 600 Dalton, it's less than 600 exists in liquid, while the molecular weight around 1540 exists in semi-solid. So as the molecular weight increases, the PEG gradually converts into the solid form. Is it clear, guys? Any doubts regarding the ointment? So some of the important extra points which I have to be to tell you guys, which is the ozo keratic, which is nothing but the saturated hydrocarbon base. Saturated hydrocarbon base. So another one is cresin, which is nothing but the combination of the ozo kerite plus paraffin wax. So these are the some of the extra new types of waxes which I have to be with you discussed, guys. So generally for the mixing of the ointments, the most widely used equipment is the triple roller mill. Triple roller Mill is used for the mixing of ointments. Is there any doubts? Is there any doubts in the ointments? Is there any doubts in the ointments? Is there any doubts? Anyone has any doubts in the ointments? Okay, so then we have to move to our next topic, which is suppositories. Suppositories. So suppositories are nothing. These are also semi-solid dosage forms. Semi-solid dosage forms, and these are generally inserted into the body cavities. Sir, kindly show the hydrocarbon base example. Okay, wait. I think so. Here you can see the absorption base. Where, which one? Yeah, you can see it here. The Oja crate and the saturated. So this whiteboard will be shared to you guys in your group. So no need to worry where you can get to access to this all material. Okay, great. So something for the ointment basis, there is a value. So let me here. I got an MCQ. Water absorption number is I for A oleogenous base, B absorption base, C water miscible base, D water soluble base. Answer to this question, guys. Which of the following ointment bases would have the highest water absorption number? Answer to this question. Answer. Read the question properly. First, the most important thing in any competitive exam is first reading the questions, understanding the concept behind the question, and then reading the options. Always follow the elimination rule. Water absorption number. Water absorption number. Guys, could you please tell me what is meant by the water absorption number? What do you guys understand by the water absorption number? What do you guys understand by the water absorption number? Obviously, something the amount of water absorbed by the 1 gram of the ointment base. Then the answer would be D. Water soluble. Yeah, great. So the answer would be the D. The water soluble bases has the highest amount of water absorption number. The lowest will be in among the following bases. Which of the following base would have the lowest absorption water absorption number? Great. It will be A. Great, guys. Great, 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 great. So next, let us start our discussion to the 1 minute. Suppository. So suppositories. So suppositories generally inserted into the body cavities. So generally they indicated in the body cavities. So suppositories, these generally melts, soften, and dissolve to release the contents of the drugs, and these can be used for the local and systemic effect depending upon the type of drug which is formulated inside the suppositories. So the most widely used method for the preparation of suppositories Guys, do you know the which method is mostly used for the preparation? Which method is mostly used for the preparation of these suppositories? Preparation method of suppositories. It is prepared by compression molding. Compression molding. So compression molding is the most widely used method to determine the which is used to prepare the suppositories. So while coming to the next, so there are types of suppositories which are administered to the different body cavities. So if there are administered to the nasal cavities, these are also known as the suppositories which are administered to the nasal are known as. Tell me, guys. The suppositories which are administered to the nasal are called as. Come on, guys, you have to be quick. The suppositories which are administered to the nasal are known as. Nasal bogies or vaginaria. Those which are administered to the vaginal body cavity are known as pessaries, and to the ear are known as yeah, orinaria. Great, guys. Orinaria. Orinaria. Mm, okay. Or ear cone are also known as, these are also known as ear cone. Ear cone. So do you guys know what is the shape of the rectal suppositories? Rectal suppository shape. What is the shape of the rectal suppositories? It's cone. It's torpedo. Great, Manisha. Torpedo. It is great. Torpedo. For the vaginal, the shape of suppositories is shape of vaginal suppositories. It is conical. For urethral, the shape is pencil shape. For nasal, the shape is cylindrical. Yeah, again, great. Cylindrical. For ear, come on, guys. Tell me the suppositories which are admission to the ear have which size? Bullet shape. Great, Vivek, great. So these are the most important shape which have to be remembered, guys. So next, so I will also mention the some of the important weights which you have to be remembered for the rectal suppositories. For the rectal, for the baby, it is 1 gram. For adult, it's 2 gram. Great. It so is it can be for the both local and systemic effect. So the vaginal suppositories are of 3 to 5 grams, and these are mostly used for the local purposes, local effect. Next, urethral suppositories for the male, it is 4 grams. For female, it is 2 grams. For nasal, the nasal suppositories also have the round apex shape. These also to be remembered, guys. Round apex shape, and the weight is 1 gram. Great. So these are the some of the important which have to be remembered. So mainly the absorption through the urethra mainly occur. 1 minute, guys. The absorption to the urethra, rectum, mainly rectum, occurs by mainly the rectum generally consists of the three types of vein. Lower, let me type, guys. Let me type for you, guys. First one is lower hemorrhagoidal vein. Next one is the middle, and third one is the upper. So mainly, if the drug absorbed by the lower and middle one, it will get directly into the systemic circulation, and the upper one, if the drug get absorbed by the upper one, then it will go to first pass effect. First pass effect. It will first go to liver. So that's why whenever a drug is administered via the rectum, there is a partial first pass metabolism because it is absorbed to the upper vein. So next, another important topic while coming to the suppositories is the solidification point. So guys, what is meant by the solidification point? What is meant by solidification point? For a suppository base, what is meant by solidification point? For a suppository base, what is meant by solidification point? Come on, guys, you have to be quick, quick, quick. What is meant by solidification point for a suppository base? Obviously, the time required for the base to solidify when it is the point at which suppository starts melting and release drug. I have asked about solidification point. I am asking about the solidification point of the suppository base. Time required for base. Yeah, great. For a base to solidify, to solidify when it is cooled. So generally between the solidification point and melting point of base, the difference should be greater than 10 degrees, should be greater than 10 degrees or more. This should be remembered, guys. Next, another most important topic, solid fat index. Solid fat index. What is meant by solid fat index, guys? Do you have any idea? SFI. Come on, guys. What is meant by the solid fat index? So, solid fat index is mainly which is used to determine the it is used to determine the solidification, melting range, of base, molding character, surface feel, and hardness of the base. So these all can be known by solid fat index. So next, for an ideal suppository base, what the iodine value should be? For an ideal suppository base, what should be the optimum iodine value? Come on, guys, answer my question. For an ideal suppository base, what should be the iodine value? Provide me the value. Come on, guys. Why not a single person is very interactive now? What happened? Have you guys get tired? It's not a time to get tired, guys. It's time to get hustle. Come on, guys. The what is the for an ideal suppository for an ideal suppository base? What is the optimum iodine value? Guys, yeah, Akshat, great. It's less than 7. Someone answered finally. Thank God. Acid value. Come on, guys. If you try to keep interactive session with the educator, it is benefit for you only, guys. It will lead to revision of your concepts. The acid value, optimum acid value. Great, Dev. It's below. It's around 0.2, around 0.2 and below 0.2. Saponification range. Saponification range. Saponification range. Come on. Fast, fast, guys. Saponification range. It should be between 200 to 245. So, guys, do you know the equipment which is used to determine the solid fat index? Yeah, great, Akshat. So, equipment to determine solid fat index. What is the equipment which is used to determine the solid fat index? This should be known by you guys. I think so. This is to be remembered by you guys. The equipment which is used to determine the solid fat index. Yeah, great, great. It is dilutometer. And do you know, guys, the dilutometer gives the graph between the which x-axis and y-axis. So in x-axis, it is temperature, and y-axis, it is specific volume. So next, so while coming to the next, the different bases which are used for the suppositories is first one is the oleogenous base, which first one includes cocoa butter, cocoa butter. The another name of cocoa butter is, come on guys, theobromo oil. Nice. Theobroma oil. The number of polymorphic form exists for the cocoa butter, cocoa butter. Alpha, beta, beta prime, and great, Vivek, great. So it consists of alpha, beta, beta prime, and gamma. So which of the following is stable form? Which form is stable form? Do you guys know which is stable? Beta. So beta is stable. So while other all forms are metastable forms, which gradually converts into the beta stable forms. So what is the liquefaction point? Liquefaction time for cocoa butter. It is around 3 to 7 minutes. And the acid value is less than 4. Acid value is less than 4. So determine the melting points of the different forms is very important. So while coming to the alpha, the melting point is 22 degrees Celsius. For gamma, it is 18. For beta prime, it is 27. For beta, it is 34 to 36. It is 34 to 36, guys. So that's why the most widely used form is the beta form, guys. So other oleaginous bases are also used, which includes the hydrogenous fatty acids of vegetable oils, which includes palm kernel oil, cottonseed oil are also used. So other bases which are used, other suppository bases used are tupo, tupocrine, vistisol, fatty bases, hydro, etc. Soluble bases. Soluble bases include glycerogelatin base, which is mainly used for the vaginal suppositories. Mainly used for the vaginal suppositories, and also the PEG base is also used, which are stable, non-irritant, stable, etc. These are the etc. So that's it for today, guys. And the remaining part of the suppositories, some of the quality control tests, displacement value, how to calculate the displacement value would be discussed in the next class, guys. So up to now, do you guys have any doubt regarding the aerosols, semi-solid doses from introduction, ointments, and suppositories up to now? Any doubts, guys? Does anyone has any doubts? Okay, great, guys. So let us meet you in next class where I'm going to start other topics where primarily I'm going to cover the evolution test for the suppositories. Yeah, I'll gonna share the table. Sir, why cocoa butter value is ideal? So why cocoa butter acid values differ from the ideal? So as you have learned, have you known that there is a no something which is known as there is no ideal thing in this universe. So there is a slight deviation from the ideal things. So there is a some slight deviation. So yeah, sure, I will send the whiteboard notes on the group, sir. Yeah, I will send sure. Do you guys have any doubts other than this? I will gonna share this whiteboard in your group. Doubts? Okay. So thank you, guys. Thank you for joining. Thank you for your patience. So let us meet in the next class, guys. Thank you, everyone.